Okay, this is our performance final study guide. So notice there are a lot of helpful equations up here that we'll be referencing. Okay, so get started. So we've got the skateboarder. We're going to be focusing on the skateboarder throughout the study guide. And the skateboarder has a mass of 60 kilograms. And we want to determine her weight. Remember, weight is also our force of gravity, okay? How much is gravity pulling on her? How much force is it exerting on her? And we can get that by multiplying her mass, m, by g, our acceleration due to gravity. Up here it says we can use 10 for g, so we're just going to use 10 instead of 9.8. So if I do 60 kilograms times 10 meters per second, that gives me 600 newtons. Okay, so that's her weight. Alright, free body diagram for when she's standing at rest on top of the skateboard. Okay, so remember that when we draw a free body diagram, we're going to draw her as a box with a dot. All our forces are going to come from that dot. And so if she's standing here at rest, we know she's got a force of gravity because we just calculated that. She's also going to have a normal force on her from the skateboard, the surface that she's standing on. And then that's it. If she's at rest, she's just standing there. There's no other forces acting. These two are going to be equal magnitude to each other, so that's why I draw the little tick marks, and they're opposite direction. What is the net force acting on her if she's standing at rest? So remember, when we calculate net force, or F net, we need to take our forces and vector sum them. In the case of her standing at rest, she has a normal force pointing up and a force of gravity pointing down. But those two we already said are the same value, so that's going to give us 0. Her net force is 0 newtons when she's standing at rest. Okay, now she begins to travel at a constant velocity in a positive direction, and we want some motion graphs. Okay, so we'll have to go back through these as part of our review. But motion graphs, position versus time, remember that's the graph of where our object is at as time goes on. When we have a constant velocity, that's a graph that looks like this, because the slope is the velocity, change in position over change in time. This gives me a constant value at every point. And if I got that number and then I graphed it as velocity versus time, it would just be a flat line along whatever that value is, because it's a constant velocity. See, velocity is on the y-axis, velocity is not changing. Okay. Imagine she jumped from a plane and dropped straight down. Draw a free body diagram that would represent the skater while she's in free fall, experiencing no air resistance. Okay, so if she's in free fall, the only force acting on her is force of gravity. That's the definition of free fall. Only thing acting on you is gravity. We said no air resistance. We don't have to worry about anything else. So that's all she would have is gravity acting on her. So the net force acting on her if she's in free fall, we said her only force would be force of gravity, and that one we actually calculated back up in number 1. So we would use m times g again here. M times g equals 60 times 10 is 600 newtons. Okay. Okay, if the plane she jumped from was 8 meters off the ground, how much time would she fall for? Okay, so this is goes back to this equation, if y'all remember. Oops. This one, and let me write it out how I always wrote it out for us. Vertical displacement equals initial velocity times time, but she's starting from rest, so that's going to be 0, plus 1/2 gt squared. This is the equation that we solve for time, okay? And we're wanting to solve for time here. So the way we did this in class was we would take our 1/2 and g, divide both sides by those. So we get 2 times dy divided by g on this side. And then we take the square root of that to give us time. You can also put numbers in. Like if that's easier for you, take this equals this and put numbers in and solve for t. This is the way we did it over and over again when we were doing projectiles. So time is 2 times 8 is our height or our vertical displacement. Divide by, we're just going to divide by 10 to make it easier. And that gives us, I don't have my good calculator here. All I have is my phone. So let's see if I can figure this out. So 2 times 8 is 16 divided by 10 gives me 1.6, and then I need to take the square root of that. Let's see, scientific, look at that. I don't know which one is the square root though. Wow, that's really annoying. Math notes? Oh, no. Okay. Hang on, I don't know how to do this. I'm just going to Google square root of 1.6. Y'all have good calculators and you have your Desmos calculator, so that is 1.3 basically, 1.27. 1.3 seconds. So it would take her, if she jumped from 8 meters off the ground, which isn't very high, and she's in free fall, then it's going to take her 1.3 seconds to hit the ground. So, okay, let me stop here and continue in the next one.